Yeah, hello everyone. Welcome to Akshara IT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Today we are going to discuss about the topic of quadratic equations. Okay. So before going to enter into this topic, let us see some of the points which are related to quadratic equations. So as we know that this is nothing but topic from algebra, right? Algebra is nothing but the mathematical branch which is depends on the variables and constants. Okay, simply x and y values are nothing but variables, numbers are nothing but constants. Okay, now here you should remember the points like what is a term, what is an expression, what is a quadratic expression. Okay, let us see what is a term. So before that, what is a constant and what is a variable? For example, if you take from a real life, the height of a plant, if you take the height of a plant, there is somewhat difference from day to day life. That means from yesterday to today, there is slight difference of the height of the plant. That means height of the plant is increasing day by day. Am I right? It is not fixed value. There is a change in the height of the plant. That is nothing but there is a variation in the height, nothing but variable. So variables, to represent the variables, we are using the letters, nothing but A, B, C or X, Y, Z, whatever. So simply from our daily life examples we can take like height of a plant or age of a person, speed of a bike. These are all we can take it as an example of variable. Very good. Now let us see the example for constant. Constants are nothing but fixed values. Height of the building. Okay, height of a building is a fixed value. Am I right? Same way we can take that measurements of a room, length, height, breadth, dimensions of a room can be taken as also a constant. So we can represent the constants with the numerical values. Numericals are nothing but numbers, okay, because they are all fixed values. They are all fixed values, right? So we have discussed about the variables and constants. Variables are not fixed values, so that we are representing with the letters. So same way constants are fixed values, so that we are representing with numericals, nothing but numbers. Now coming to the topic of the term, the definition of the term is nothing but the combination of letters and numericals together, or only letters we can take, or only numericals we can take, or their combination with multiplication symbol is nothing but term. Okay, na? Nothing but x is a variable, 7 is a constant. 7 into x, 7x is a term. Am I right? Yeah. Now coming to expression. Expression is nothing but combination of terms with plus or minus symbols. Combination of terms with plus or minus symbols is called an expression. Now let us go through the topic. The topic is nothing but quadratic equation. First of all, let us see what is a quadratic expression. Quadratic expression. Quadratic expression means an expression which is in the form of ax square plus bx plus c is called quadratic expression, where a, b, c are called coefficients which are belongs to complex numbers or real numbers. Am I right? Yeah. A, B, C are belongs to real numbers or complex numbers. How can we say that it is a quadratic expression? If you're taking about the expression whose degree 2 is called quadratic expression. An expression whose degree 2 is called quadratic expression. So what is degree? Degree is nothing but when you're taking the terms here. How many terms are there? 1, 2, 3. Total 3 terms. In the 3 terms, while you're observing, the variable is here considered as x. Variable is x. A, B, C are constants, are coefficients. Okay. And while you're observing the exponent of the variable, among the three terms, highest exponent is 2, so that the degree of this expression is 2. We can call this expression as quadratic expression. Am I right? Yeah. So whenever the quadratic expression, which is in the form of ax square plus bx plus c, and we should understand that a, b, c are coefficients. Okay, right. Now coming to the quadratic equation. Quadratic equation is nothing but quadratic expression. When you make it equals to 0, it becomes a quadratic equation. Okay. Now while you're taking, for example, let me take an example. For example, 3x square plus 5x minus 6 equals to 0. It is an example for quadratic equation. While you're taking this quadratic equation into the graphical form, quadratic equation, try to represent into the graphical form, it will give you the shape of parabola. It will give you the shape of parabola. Parabola is nothing but, it is looking like union shape, or it can be looking like intersection shape also. This shape also can be called as parabola, and it is also can be called as parabola. It is called open upwards parabola, open downwards parabola. That means if you take a quadratic equation and try to represent the quadratic equation by taking the points or by taking the values in the place of x and represent in a two-dimensional shape, nothing but using the coordinate geometry, it will give you the shape as parabola. Okay, let us go through the next one. Now from this, let us see the types of a quadratic equation. First one, pure quadratic equation. There are some different type of quadratic equations. Among that, first one is pure quadratic equation. That means an equation, I am telling the definition of the pure quadratic equation by using the standard form or general form of a quadratic equation. What is the general form? Ax square plus bx plus c equals to 0. So in case in this equation x term is missing, that means x term becomes 0, then such type of quadratic equations are called pure quadratic equations. Okay, na? That means 3x square minus 5 equals to 0 is an example of pure quadratic equation. Simply, in a quadratic equation, the coefficient of x term becomes 0. Such type of equations are called pure quadratic equation. Okay. Now coming to monic quadratic equation, we know the meaning of mono. Mono is nothing but 1. Mono is nothing but 1. That means while you are observing that quadratic equation, ax square plus bx plus c is equal to 0, the coefficient of highest power. Coefficient of highest power means x square coefficient is becomes 1. That means if a value becomes 1, if you take any quadratic equation, x square coefficient is 1, such type of quadratic equations are called monic quadratic equations. Can you identify the difference between them? Pure quadratic equation means x term becomes 0. Now here, monic quadratic equation means x square coefficient is becomes 1. Okay. Now let us see. Till we need to discuss about the root of a quadratic equation and nature of a quadratic equation. Okay, simply we have some types of quadratic equations also there. Among that, we have discussed about the pure quadratic equation and monic quadratic equation, and also we have discussed about the shape of a quadratic equation when we represent into the graphical form. Am I right? Now coming to the root of a quadratic equation. What is the root of a quadratic equation? We can call it as root of a quadratic equation, or 0 of a quadratic equation. 0 of a quadratic equation. We can call it as root of a quadratic equation or 0 of a quadratic equation. For example, if you take in the place of x, nothing but in the general form ax square plus bx plus c is equals to 0, the variable is here x. The quadratic equation in the variable of x, if you take any value in the place of x, definitely for certain value the given quadratic equation becomes 0. For certain value the given quadratic expression becomes 0. Such value is called root of a quadratic equation or 0 of a quadratic equation. Okay na? For example, while you are taking the degree 2, any quadratic equation or any quadratic expression, according to its degree, there are that many number of roots are involving. Nothing but its degree 2, simply we can say that there are 2 roots for this quadratic equation. If you take that cubic equation, there are 3 roots. If you take cubic equation, there are 2 roots. That means if you take any quadratic equation, definitely it will give you the answer in the place of x. When you substitute any real number, definitely it will give 2 real numbers, answer is 0. Okay, right? So that if you know that roots of the quadratic equation, for example, let me take the alpha, beta or the roots of a quadratic equation, then the quadratic equation is x minus alpha into x minus beta equals to 0. Am I right? That means simply you know already that is how you factorize the quadratic equation. That means the quadratic equation degree is 2, nothing but it is having 2 factors, nothing but 2 roots. That means a quadratic equation can be written as product of 2 factors. I have taken that alpha, beta are the roots. Then we can express a quadratic equation in the form of x minus alpha, x minus beta equals 0 according to the factor theorem. Try to multiply this one, x into x, x square, and x into alpha, x alpha, and x into beta, x beta plus alpha beta equals to 0. Okay, so that x square, if you take x as a minus x as a common term, then alpha plus beta plus alpha beta equals 0. This is the quadratic equation if you know the roots of the quadratic equation as alpha beta. Okay, now let us try to identify the relation between roots and coefficients of quadratic equation. Actually, what is the general form? Ax square plus bx plus c. That means there are 2 roots or 2 zeros will be there. When you take that alpha beta are 2 roots, we know that x square minus x into alpha plus beta and alpha beta equal to 0 is in the format while using that alpha beta or roots. Now try to compare both of them. X square coefficient here 1. Here x square coefficient is a. Okay, x square coefficient is a. And what about that x coefficient both of the sides? X coefficient is here b and here alpha plus beta. That is nothing but minus alpha plus beta is equals to b. Simply we can say that alpha plus beta is equals to minus b. Okay. Now constant terms, when you compare that constant terms, alpha beta equals to c. Am I right? Yeah. Now from this I can say that alpha plus beta is equal to minus b by 1. Can I write minus b by 1? According to the x square coefficient, 1 is nothing but a value. So simply we can say that it is minus b by a. Same here also, I can write it as c by 1, nothing but c by a. So that when you take alpha and beta are roots, sum of roots alpha plus beta is equal to minus x coefficient by x square coefficient. Okay, sum of roots. I have told you that let us identify the relation between coefficients of a quadratic equation and the roots of a quadratic equation. I have taken the roots alpha beta. When you add it, sum of roots value you are getting minus x coefficient by x square coefficient, simply minus b by a. Same way, product of roots alpha into beta. Alpha into beta, product of roots is equal to c by a, nothing but constant by x square coefficient. Clear? Right. Now let us try to discuss about the nature of the roots. Nature of the roots. Yeah. So we have discussed the shape of a parabola. Let me try to draw the shape of a parabola by using the coordinate axis, x-axis and y-axis. Okay. Here also I am taking that coordinate axis x and y, and here also I am taking the coordinate axis x and y. So point of intersection is origin, we know that. Okay. Because while we are taking the quadratic equation, it is in the shape of parabola, I can identify three different shapes. Three different situations, not shapes, three different situations for parabola. That means that parabola can be intersect x-axis at two different points. This is one situation, and the parabola intersects x-axis at only one point. Okay, only one point. And this one, it may not be intersected. There is no intersection point between parabola and x-axis. And as we know that when you take that x values where the graph or nothing but parabola intersect x value, you are taking as a solution or root or zero of a quadratic equation. Okay, now that means in this case, that means case 1, we are having two different roots. How many roots are there? Two different roots, because the parabola touches the x-axis at two different points. Okay. Now here the parabola touches only at one point. Here also two equal roots, because according to the definition its degree is 2. So we can say that there are two roots. The two roots are equal. Two roots are equal. In the first case, two roots are different. In the second case, two roots are equal. In the third case, there are no roots. There are no roots means there are no real roots. That means the roots are in the format of complex numbers. The roots are in the format of complex numbers. That means we are taking that there are no roots situation here. Same way, same as it is, we can take the parabola downwards. That means in the first case, we can say like this. It can be touches the parabola x-axis at two different points, only one point, and there is no point. Clear? Sir, according to the graph we can say, but is it possible wherever you wanted to draw the graph? Is it possible? Is it because the construction of graph or representation of a quadratic equation in graphical form, there is time taken process. Am I right? Every time we cannot take that graph sheets and we cannot plot the points. We can plot the points, but it is taking more time. So can you guess any other alternate method for this? Yes, obviously, for that to identify the nature What is the nature we are getting? There are three different type of situations we are found it here. What is the situation? That there are two different roots of a quadratic equation. There is only one root that is having a quadratic equation, and there is no root situation. The three situations we can take it by finding the value of discriminant. Which value? Discriminant. Yeah. So nothing but delta. We are representing with discriminant value with delta, nothing but b square minus 4ac. Whenever taking the quadratic equation in a general form like ax square plus bx plus c is equals to 0, when you identify the b square minus 4ac value which is greater than 0, we will get there are two different situations, there are two different roots. Equal to 0, there are two equal roots, and less than 0, no roots, no real roots. Let us see an example. Example like 3x square minus 5x plus 4. Okay, let me take this example. Compare with general form. From this we can say that a value is 3 and b value is minus 5 and c value is 4. Now try to find out the b square minus 4ac value. I am finding here b square minus 4ac, b value is minus 5 whole square minus 4ac. 4 into a value is 3 and c value is 4. Minus 5 square is nothing but 25 minus 4 into 4, 16, 16 3s are 48. So 25 minus 48 is nothing but minus 23, which is less than 0. Minus 23, which is less than 0. This is one example. Let me take another example also. 2x square plus 4x minus 2. Again compare and identify the discriminant value. So there are 4 square, b's value is nothing but 4, b square minus 4ac. A value is 2 and c value is minus 2. Now here minus or minus becomes plus. 16 plus 16 is 32, which is greater than 0. So in this situation, while you're taking this quadratic equation, this equation we are getting less than 0. In this equation we are getting greater than 0. So greater than 0 means there are two different roots, and less than 0 means there are no real roots. And what about the equal to 0? That is nothing but x square plus 4x plus 4. Let us try to take this one. Compare here b square minus 4ac, which is nothing but b value 4 square minus 4ac. 4 into a value 1, c value is 4. So 4 square value 16, here also value 16, which is nothing but equals to 0. So this equation gives the two equal roots. Clear? So by identification of roots, we can use the discriminant formula. Very, very important, discriminant. Whether the discriminant value greater than 0, equals to 0, less than 0. Greater than 0, two distinct roots. This situation. Equals to 0, only one root, nothing but there are two roots, both roots are equal. Now here, less than 0, there are no real roots. That means in this situation, parabola touches the x-axis at two different points. In this situation, parabola touches at only one. Here less than situation, there is no connection between parabola and x-axis. Okay? Yeah, that's it for today, children. Thank you one and all. I hope you all enjoy this class. Thank you one and all. Have a nice day. Bye-bye.